Hi class, in this video we'll be covering MATLAB basics, variables, and arrays. As with all computer programs, we must understand how to speak the language. We call these lexical elements, lexical for lexicon or words. So we need to learn the words for programming MATLAB. So for MATLAB, the language, there are operators, there's the assign to, there's the unary plus, unary minus, matrix division, that's left division. This is multiplication for matrices. This is a less than, and there are many other operators that you can use. There are also special characters such as the percent, which is the comment. There's also the semicolon, which can suppress an output, and the continuation, which is the dot, dot, dot. And we'll learn about these more throughout this class. There are also names. So there are names of variables that you could assign, such as a, lowercase x, a and s. There's also variables that are built in, such as pi, pi. There are also names for functions. There are some built-in functions, such as the sine and exponent function, as well as functions that you may write. And there are also reserved words, such as the break, clear, for, and others, such as end. There are also data types that we have discussed, such as double, ints, chars, logicals, and many more, including cells, tables, and we'll go through those throughout this class. These lexical elements that we've covered can be used to make statements, such as expressions, where we evaluate a mathematical expression, which is, in this case, 3 matrix multiplied by the variable x plus 2. We can also assign things, such as assign to the variable height the value 6, or assign to the variable area the value 4 times the sine function, and input to the sine function pi divided by 2. We can also have commands, where we enter clear, CLC, and throughout this course, when you see these two greater than signs next to each other, that's actually, I'll show you shortly in the command window, that signifies that you're going to be entering a new line of code into the command window, and when you press enter, that line of code would execute. So let's take a look at the command window, which is one place where we can enter in statements to MATLAB. So we can enter in the statement that we just talked about, one of them, which was 4 matrix multiplied times the output of sine, enter into that function, value pi over 2, and then add 5. And so this is just adding in a statement. You'll notice here in the workspace, I don't have any variables yet. So when I press enter and evaluate this line of code, and so like I said, these two greater than signs here will be for the next line of code that you're about to evaluate. So if I press enter, you'll see now there's a new line that I can enter code on, and it'll also output your answer. Since I did not assign this expression to any variable, MATLAB defaults to putting that to a and s. So now there's a new variable in my workspace called a and s, and it has the value 9 because, of course, 4 times sine of pi over 2, which would evaluate to 1 plus 5, should equal 9. So this evaluates as we would expect. As we've just shown, we can use MATLAB as a powerful calculator. But if you'd like to assign the output to a certain variable name, we can use variables to store a reference location that will store the value. To do that, you need to use the assignment operator, and that is this equals operator. For example, here we're assigning to a variable, which is called variable name, the value from another variable expression, or this could even be a mathematical expression that's being evaluated. As we've seen already, the default variable, if no variable is named, will be a and s. So if you do not assign the output of an expression to a variable, it will go to a and s as we have just seen. So you can declare a new variable via variable assignment using the equals, which is actually not an equal sign, it's the assign to operator. And you cannot use an undeclared variable. For example, if you have a variable named A and you want to assign to it some variable B, but you have not assigned variable B yet, there will be an error. In order to create a variable in MATLAB, you must have a valid variable name. A valid variable name in MATLAB will start with a letter, so it must start with a letter, and it can be followed by letters, digits, or underscores. You cannot have the @ symbol, the hashtag symbol, a space, exclamation mark, period, etc. So a valid variable name can only start with a letter. Once you start with a single letter, you can be followed by digits or underscores. So for example, here, x6, because it starts with an x and then the 6 comes after x, that would be a valid variable name. Last value would be a valid variable name. N underscore factorial would be a valid variable name. Invalid names would be, an example here would be 6x, because the first character is not alpha numeric, it's a number, it should be a letter. So this would not be valid. End is already a reserved variable name, so you cannot use end. And also n exclamation mark, maybe you wanted to say, oh, this is n factorial. Well, that is not a valid character to be used. Also, if you wanted to do something like last space value, that would be an incorrect variable name. You cannot use reserved words such as n, like we discussed. Other words are break, clear. If you want to check if the word you want to use is a reserved word, you can enter in the function is keyword followed by the variable name you'd like to use, and MATLAB will tell you if that is already taken. So one very, very important piece of information is that variable names are case sensitive. What that means, for example, if I had a variable with a capital A, so area spelled with a capital A, I made a variable for that, that would not be the same as if you tried to call the variable area with a lowercase a. These variables are not the same because this is case sensitive. So this is very important that you follow this, otherwise you'll be making errors. And it does have a theoretical limit for MATLAB, but usually this is practically not going to be an issue for you. And the final thing is that it should not be a already existing function name, such as pi, sine, exponent, etc. And you can also do help with the variable. That'll tell you if it's already an existing function, because if it shows up, for example, if you type in help sine, it'll tell you what the sine function does. So you don't want to reassign to that. Another tip is that, and you'll get practice with naming variables, but you should choose variable names that are meaningful and descriptive of the problem. For example, if I'm calculating surface area, make a variable that is very descriptive. It's okay for it to be long. This doesn't take up more space in MATLAB. So I'm calling this variable surface underscore area, not some arbitrary variable such as y or x or y1. This is not readable. So if somebody else came to your program and wanted to know what is y, they would have to dig through your code. Hopefully you've commented it, and we'll explain good practice around that. But best practice for variable names is to be as descriptive as possible. Also using camel case, such as a capital S and a capital A for area, makes it a little bit more readable. And the underscore can either be dropped or not, but it kind of will make a space. If you wanted to have a space in here, of course, space is not a valid character. So there's some tips along with naming. So one reason we might want to have a variable name is because I may want to do another calculation, like I might do 3 times cosine of pi, and if I do that, it'll reset the value of a and s. So now I no longer have stored the value from my previous calculation. In this command window, you can use the up arrow. So if I click up, I can enter in that last line. And instead of just assigning this to a random variable a and s that will be overwritten, I could say, hey, maybe let's make this lowercase a. So assign to that value. Now, one thing I could do here, like I said, is use the semicolon operation. So you notice before when I entered into the command window, there was no semicolon, and then it output this ANS. So if I have a semicolon, it will suppress the output to my command window. That doesn't mean it's not going to execute this line of code, so it will. So notice over here in the workspace, I only have one variable, that is ANS. When I press enter, I didn't get an output to my command window. But you'll see now in my workspace, I do have a variable A with the value 9 stored to it. And if I wanted to say like, hey, what is in A? So let's do capital A. I might be sloppy. Is that anything? And it will tell you, no, this is an undefined function or variable A. And actually MATLAB now, since it knows, hey, this is close, it'll prompt you, say, did you mean lowercase a? And if I tried to set that equal to, say, some other variable b that I have not created yet, it'll also tell you that b is undefined. If you want to know if there is a word, so type in is keyword, let's try end. And the answer says logical. That is true. This is a Boolean, so a logical set. If it was 0, that would mean it's not. So you could say is keyword, let's try the variable b. And it gives you a false. So no, that means that you could use b as a variable. You can also try help, and let's try sign. Like I might want to do sign. And what it will tell you is it actually gives you a description of the function sign. It says sign argument in radians, and it'll tell you the sign of x. X is actually just a variable. They're saying you can input a variable to the function sign, and it'll calculate that, and it assumes x is in radians, which is why we used pi over 2 for 90 degrees. If you did help capital SIN, it will say refer to sign. So it was close enough, but actually sign capital. So if I try SIN of pi over 2, it's going to give me an error. It's going to say that is undefined function or variable. So MATLAB is very case sensitive. It's very important. And like I said before, like I might want to make a variable called surface area. So I go ahead and type in surface area, and what you'll see here is it's starting to make the second word purple, and that's to alert you that this is not a valid variable name, but I could try anyways to, like, let's just assign that value. So remember, equals is not equals, this is assign to this variable on the left, the value 5. Unfortunately, that's an invalid name. So what I need to do is give it a valid name. And one way would be to, with camel case, you could delete the space and you can pretty much read that. But if that's still not readable enough for you, you may want to add an underscore. And when I do that, you'll see I've created now a variable surface area A. I didn't have the semicolon, so it assigned to it. It let you know, hey, surface area is now a variable with the value 5. So when we're trying to assign to a variable, a common mistake might be like, oh, okay, I want to assign to the variable, let's just say x, so say 4 equals x, and this may seem okay because I've got a 4 here and I've got a assign to operator and I've got some new variable x. So it says, uh-oh, you can't do that. Why not? Well, first bet is to read the error message. So here it says the expression to the left of the equal sign is not a valid target for an assignment. That's because when you use the assign to or equal sign operator, what MATLAB expects as it reads left to right is there should be a variable name on the left. Now 4, as we know, is not a valid variable name because it must start with a letter. So the order here was wrong. If we redo it and say x equals 4, I could actually suppress this output. And now you'll see in my workspace, I have a variable x assigned to it the value 4. If you would like to clear a variable from the workspace, you can use the clear function. For example, if I want to clear the variable x, I can say clear followed by x. you will find that X is removed from your workspace. If you'd like to clear all of your variables, you can say clear all or clear vars. I like clear vars. So clear vars will now clear all of the variables. So now there will be nothing assigned to the value A. Just to show you that it's no longer in memory. If I type in A, it now says that is an undefined function or variable because it has been cleared from my workspace. Up to this point, we've only stored one value in our variables. However, MATLAB is actually short for Matrix Laboratory. What does that mean? Well, it actually means that we can store much more than just one value and assign it to a variable. And in MATLAB, what we can actually store are vectors and matrices, and actually not even just 2D matrices, we can store ND matrices, which we'll get to at some point in this class. One example of this will be how images are stored in RGB with 3 matrices stacked on top of each other. Okay, so arrays are composed of rows and columns. So here are 2 examples of arrays. There's an array X and there's an array Y. The size of array X is 1 by 3. We say it's 1 by 3 because the row is given first and there are 3 columns. So there is 1 row and 1, 2, 3 columns. Y size would be a 2 by 3 because there are 2 rows and there are 1, 2, 3 columns. In order to make an array in MATLAB, what you need to do is use the brackets. This tells MATLAB we are making an array. So anything inside those brackets, and remember this would be assigned to the variable X, the value on the right. Since there are brackets, we are assigning an array. You may use brackets to even assign a 1 by 1 array, however that is not necessary. So what we're defining here is actually X as a row vector. The commas or spaces can be used to indicate new values. And to end the array, we'll end it with the bracket. To make this 2 by 3, what we would need to do is tell MATLAB we need a new row. In order to do that, you can use the semicolon. The semicolon, when referenced inside brackets, indicates to MATLAB we would like to add a new row. A particularly useful tool when it comes to making arrays is the colon operator. So you can create long arrays of uniformly spaced values using a colon array, and I'll show you this. So basically there is a start value, an increment value, and an end value. So here we're using green to show you that that's the start value. That's always the value on the left. The middle value in between 2 colons is taken as an increment, and then the end value is taken as the last value. So in this case, we're assigning to the variable leap years, and it's the camel case, so you can easily read it, the values from 2000 step by 4 to 2020. B is being assigned 9 is the start value, and the increment is negative. So you can increment positively or negatively. So you would step from 9 by -2 to 0. If you leave out the increment, so if there are only 2 values specified in between a colon operator, that is taken in MATLAB to have an increment of 1. So this would be assigning to the array A values 1, 2, 3, 4, 5, 6, 7, 8. So let's take a look in the command window how we can go about making arrays. So prior to this, we had assigned to the variable X the value 4, and that's just a 1 by 1. So if we'd actually like to store more values, for example, make a row vector, we can use the brackets. So right here, I've assigned to row vec, short for row vector. Now remember, this is a valid name because there's no spaces, there's an underscore, and there's also starting with a letter. Okay, and what you see here is it's printed out to the screen, the vector as 2, 3, 4, 5. And now you can see in my workspace, it shows that the size is 1 by 4. So I've created a row vector. This could have also been accomplished using commas. So, and actually adding extra spaces in between doesn't make a difference. There just must be a space. If I delete the space between the 4 and the 5, it's going to make that a 1 by 3 with the last value being 45. So make sure you have spaces. It just doesn't matter how many. You can also, if you don't want to use spaces, you can use commas. So you could do 2, comma, 3, comma, 4, comma, 5. And that accomplishes the same thing. Well, another way, instead of having to write all values 2, 3, 4, 5, you'll notice that these are regularly spaced by 1. So I could have actually said row vec, and let's just call this row vec 2 because this is a different one. Let's use the colon operator. And the colon operator, you don't have to have brackets, so you can just go to 5. You can also, so I left out the 1 since there's only 2 values here. I didn't have to have the step, but you could include the step. That won't make a difference. It'll still step by 1, so that's the same thing. You can also put it in brackets. You don't have to, but you could. So one thing I can now do is I can now concatenate these. And so I could say row vec 3 is the concatenation, and I'll show you that shortly, of row vec. Oh, and I should say this now, is that if you double click on any variable in the workspace, it'll kind of show up in table form here. So it'll show you the data type. This is a double, and it'll give it to you in table form. Your command window gets shrunk down. You can drag this back up if you'd like to see more of your command window, or you can just close it. So what I wanted to do was actually make a new vector, and this is actually going to be an array, a matrix. So let's call this row vec 3, concatenate row vec. So actually one good way to do this is, since it's case sensitive, is to just copy and paste. That way I don't have a mistake. And let's do that. So what this will do, we'll stack them together. So now I basically sandwiched those 2 vectors together. Because I added a comma, what that has done is just add the second vector and it continues on the row. Now, alternatively, if I added a semicolon, recall that a semicolon will say add this next vector on the second row. So this will actually make a 2 by 4. So now you see row vec 3 has 2 rows and 4 columns. And you can see now in your workspace that it is a 2 by 4. I really like having the size in here so that I can easily see what the size of the vectors are. And that's actually important because what you'll see is it can show you how you may end up creating an error. So if I wanted to make another vector, let's call this row vec 4, and let's just say this is, I'm going to concatenate row vec 3, and I want to stack on top of it another array, and let's just stack on top of it 1, 2, 5. So I'm basically saying on the third row, I want to put the vector 1 through 5. What you'll see is that I'll get an error, and it says error using vertcat. That's saying the concatenation vertically does not work, and that's also tells you that the dimensions must be consistent. This is very important when you are making a row and column array. The columns must match up. The reason why this didn't work is because I try to stack on top of or underneath a 2 by 4, 1 to 5. And let's see what 1 to 5 actually is. I'll just type that in my command window. And what you'll see is this is an ANS, it's a 1 by 5. Since this has 5 columns, I cannot put it underneath a row vector that has 4 columns. So that would not work. So if I go back up and you size this appropriately, so now this is a 1 by 4, you'll see that it works correctly. So whenever you're concatenating vectors together or trying to make an array or a matrix, you need to make sure that your rows are consistent and your columns are consistent with the things that you are trying to concatenate together. Another thing to know is that if you're using the colon operator to make an array, let's say we want to start at 3 and step by 1, so we don't actually need to put that 1 here, but let's just say let's stop at the value 2. This is going to cause A to not have anything, so it assigns to A just an empty vector, so there's nothing in it. It's a 1 by 0 because you cannot have a finish value that is below your start value if you're stepping by positive 1. If you wanted to step by negative 1, then you can have the value 3 and 2 assigned to array A. Along with stepping negatively, you also do not have to step by full integers when you're using the colon operator. So for example, I could say the variable b, let's make this an array, and we're going to step by 1/4, so a step by, and you can actually do math in here. So you can do 1 divided by 4 as my step value. That's just a value, and step 2, let's say 2. And it'll step by 1/4 from 1 to 2. If your start value and your increment, so let's just say I'm going to say C is equal to 1, let's just step by 2 to 4. What you'll see here is when I step by 2, it's going to stop at 3 because it needs to take increments of 2. So it will add 2 to 1, but it will not stop at 4 because if it takes another step, it would give the value of 5, which is greater than our stop value, so it'll stop just at 3. So even if your stop value is indicated, you may not get that stop value if your step doesn't get you all the way there. Another very useful operator when operating with arrays is the transpose operator, and that is the apostrophe. So if I want to make, so C is a 1 by 2, but if I want to rotate it or transpose it, which if you've taken linear algebra, what you know that means is to rotate your row vectors into column vectors. So let's actually, just so you can see, I'm going to type in row vector 4. So row VEC4. Uh-oh, it gave me an error. Why did it give me an error? Because it's case sensitive. So I typed in a capital V, and there is no variable row with a capital V for vect4. And MATLAB recognized that I meant row vect4 with a lowercase v. So what you can see here is that this vector is a 1, 2, 3 by 4. If I want to transpose this, I can take that vector and put a apostrophe right next to it. This apostrophe operator, when next to an array, will transpose it. So what you see here is now that this first column was made into the first row, and the second column was made into the second row, and the third column was made into the third row, and the fourth column was made into the fourth row. So now ANS, remember row vec4 was a 3 by 4. When transposed, it becomes, and it's been assigned to the variable ANS, it has been transposed and it becomes a 4 by 3. So your rows become your columns, or your columns become your rows. Two very useful functions when it comes to building arrays, and especially initializing arrays, is the zeros and ones functions. So if you type in help zeros, sorry, I just need to spell that with a Z, it'll tell you what the function does. And what it does is create an n by n matrix as a matrix of zeros. So if you only specify one value, it's going to give you a square matrix. If you specify two values, it'll give you an m by n matrix of zeros. So let's try this. So let's just make capital A. Let's assign to that variable an array, and let's do zeros. And let's just make this a 3 by 3. So now it created a 3 by 3 array of zeros. If I had said A equals zeros, 3, 2, it would make a 3 by 2 array and assign that, or matrix, assign that to A. Ones is the very similar, except instead of populating your matrix or array with zeros, it would do it with ones. So I could say a ones, it assigned to a ones 3, 2, and that will give you a 3 by 2 matrix of ones. Now that we know how to make arrays, it's very important that we know how arrays are indexed. And what I mean by that is every single element or number or character that's in an array has an index or address for that number within the array. So this allows us to specify which elements we would like to modify. The convention for this is if I had an array Z, would be using the parentheses. Inside the parentheses, I could ask for you could give a row or column. And I'm showing these in brackets here because you can actually use arrays to specify the array that you want within Z. We'll get to that. So for example, if I had a matrix here, Z, which is a 4 by 4 matrix, it has addresses. And what the address is since this 0 is in the first row and first column, it is the 1, 1 address. If you step down to the second row, the address for the 1 over here is the second row, first column. So it's the 2, 1 address. This 3, since it is in the second row and the third column, has the address 2, 3. In fact, this is an m by n matrix where it was a 4 by 4 matrix. So this last element here, 1, in the very lower bottom right is 4, 4. That should always match your size, that address of your matrix. So for example, if I had this array Z in MATLAB, if I typed into my command window 2, 3 in parentheses next to the array Z, this would have to be capital Z, so the case is very important. What it would do, it would return the element in the second row and third column. So in this case, I've got an example Z, and I've created a different matrix using the magic function, but it's still a 4 by 4. So if I were to say Z and in a parentheses 2, 3, that would get the element from the second row and the third column. So that should return the value 10. Okay. And since I didn't assign this to any variable, it's just assigning it to the random variable ans. If I were to assign it to say a, I could overwrite the value a. So a is a 1 by 2. That doesn't matter when you're reassigning to a, if I'm reassigning a 1 by 1, because I'm just saying whatever a was, now assign it to be a 1 by 1. So I could say a is equal to Z, and let's just say the first element of Z. So 1, row 1, row 1, column 1. And now the value 16 that was in matrix Z has now been assigned to A. Now I didn't get rid of the value from the first row and first column in Z. In fact, I'll double click on this so it may be an easier format for us to view as we go through this example. So now in the first row and first column, there's a 16. That's what we've assigned to A. Now, what if we don't want to assign just one value to A, like what if we wanted A, it was a 1 by 2, what if we wanted to get two values? Well, in this case, what we could do is say A is Z, but let's get the more than one column. So because it wasn't 1 by 2, we wanted two columns. So what if we took column 1 and column 2? It doesn't like that. Well, that's because I need to feed it an array. So remember when earlier I showed you the sort of syntax for this is array that it sees on the left will be taken as the rows, and the array on the right will be taken as the columns. If I were to redo this statement, but make 1 and 2 an array by putting it within the brackets. Now what it will see is take from Z first column, and now I've given it an array of, first row, I've given it an array of columns I'd like. So this is saying I want to take column 1 and 2. So now I've got the values 16 and 2. Of course, I could have also used the colon operator here, and I could drop the brackets. So I could say 1, 2. Now I actually like always putting in the brackets in this case so you know you're doing it right. And in fact, not just that you could do columns in order, I could actually do columns out of order. So pressing the up arrow to access this, but I'm going to change column 2, and let's say actually we want column 4. And now it got the elements from the first row, first column, and first row, fourth column. So that's the 16 and the 13, and they have been assigned to the variable A. If I would have said, hey, let's try to get something from the fifth column, it will throw an error because there is no fifth column in matrix Z or array Z. So it says index, this 5 index exceeds matrix dimensions. In fact, we can even get more than one row. So I could say, let's take the rows as an array. So let's say 1 and 3. And let's go ahead and take those and assign them to A. So what will that do? Well, what it'll do is make, oh, and I still forgot to replace my 5. This should be 4. So what that will do is take arrays of values from columns 1 and columns 4, just like before, but now we're also specifying it's going to be row 1 and row 3. So what that would do would be taking the 16 and the 9 and the 3 and the 12. And what you'll see here is since I'm asking for 2 rows and 2 columns, I'm getting a square matrix now to the variable A. Now you see the size is 2 by 2. It is square because I have a 2 by 2 that I've requested. So you can ask for multiple elements at once because they can be addressed using this parentheses bracket. But what if you wanted to take more than just a couple rows at a time? What if you wanted to take all the rows at the same time? There's an operator for that, and that in this case is the colon operator, which we've seen before for making arrays. But if the colon operator is taken in context of parentheses next to an array, it's a different operator because it's in context of array indexing. In this case, it means all elements in that row or column. So for example, if I was having this array Z and I said Z and had next to the Z parentheses, this is saying the third row, and this colon operator is now specifying that all of the columns should be taken. So what is this? Well, if I take the third row and all of the columns, I'm making a row vector, and it's a 1 by 4 row vector. So what this would return would be the vector 6, 4, 2, 1. And since I haven't assigned it to anything, it would just give it to A and S. If the colon is on the left where the rows should be, this will say take all of the rows and then column 4. So this would be a column vector. In this case, it's all of these ones right here. So it would appear ANS as a 4 by 1. So this other answer was a 1 by 4, so that's a row vector, but now we've created a column vector. Another important operator when it comes to array addressing is the AND operator. So the AND statement, when it's in parentheses next to an array, refers to the last row or column. So for example, if I had Z and then the parentheses is saying, I want to get these addresses, the variable value 3 as the row, and AND, what that's saying is take the third row, and when it sees end for a column, it will just automatically know it will take the last column. So for example, this would take the value 1 and assign it to ANS. What's really nice about it is that it understands what the number end is. So for example, if I in parentheses had for the rows end minus 1, that's saying take the last but minus 1. So instead of this row 4, it's actually row 3. And in this case, I'm requesting columns 1 and columns 3. Remember, if you're requesting multiple rows or columns, make sure to put it in brackets. So this would get the values 6 and 2 and assign it to the variable ANS. Another way that we can index arrays is with column indexing. So if in the context, for example, there is not a row, comma, and a column inside the parentheses, just one array, what that would say is MATLAB would interpret that as column indexing. So let's take a look at another array Z. And over here on the right, I'm showing you what the addresses are. And the way MATLAB addresses it is descending the columns. So instead of going across the rows, it goes down the columns. So the first column in the address would be 1. Then it would go down and assign 2. And then now that's it for the first column. So then it would hop to the next column and assign the following address. So the 3 address in this case would be the, well, if we were using the row column indexing, 3 is where we would have the address 1, 2. But if you only give one value, that's the column indexing. So here is an example. If next to the variable Z, I put parentheses and just the value 3, it would get the value from the array Z that is in the 3 column address. That is the value 4. If I ask for more than one element, but I don't have a comma in between arrays. So if you put it in an array, this won't say this is the first row, 4th column. This is actually one array, and since I'm only passing one array for the indexing, MATLAB sees this as column indexing, and what it'll get is the 1st, 4th, and 5th address. So that would be the 6, the 10, and the 2. So it would assign to that. And this array right here, there's 1, 2, 3 values, and there's 1 row and 3 columns. So this is a 1 by 3. A very interesting thing and very useful is if you want to get all the elements out of an array, and especially an array that's in matrix form, but you want to get them in vector form, this is an extremely useful tool, is the colon operator here. And remember, that means all when taken in context of array addressing. So if I do this, but with column indexing, what it'll do is give it in a vector form. So it just goes along. So the 1 address would be first, the 2 address would be second in the column vector. And since this was a 2 by 3, which means there are 6 addresses, it's going to give you a, well, there's 1, 2, 3, 4, 5, 6 rows and 1 column, so a 6 by 1. Since knowing the dimensions of arrays is very important, as we've already seen when we try to concatenate arrays of different sizes, that would cause an error. So it's very important to know what the dimensions of arrays are. Sometimes you don't know what someone else's variable array dimensions are. So MATLAB has given us some useful functions. For example, whose, and if you type the array that you'd like to see, so in this case, I'd like to see the information on array Z. What it will give you is the size, so it's a 4x4 array. It'll also give you the data size, so this is taking up 128 bytes of data. It will also give you the class of the values within array Z. For the next part of this, I'd like to make Z a 3x4, so I'd actually like to eliminate the fourth row of Z. One way I could do that is say Z is equal to Z, but I'm only going to take rows 1 and 3. So how could 1 through 3? So I could say take Z, and remember, if I want multiple rows, I need to give it as an array. So 1, and I don't have to type out the array 1, 2, 3. Well, that would be perfectly fine, but I could also say just 1, and I don't even need the brackets, but I'm going to do it here just so you see that I'm passing in an array. If you recall, this colon operator would step by 1 from 1 to 3, so that is going to say give me rows 1, 2, and 3. And then let's say we want all of the columns. So how would I do that? Remember, in the context of addressing, so this colon is in the context of making an array. But if I give it here, it's in the context of addressing. And what that says for MATLAB is, in this context, it says, give me all of the columns. So what this will do is basically say, take columns 1 through 3, sorry, take rows 1 through 3, and give me all of the columns and reassign that to Z. So whatever Z was, we're reassigning. So what you'll see now is we've gotten rid of the fourth row. So now Z, if you look in your workspace, is a 3x4. So if I retyped in whose Z, what you're going to see is you're going to get a 3x4. Another very useful tool is the length tool. It'll tell you the length of the longest dimension. So if I go length of Z, what that is going to give me is the value 4. Now remember, if I did Z and transpose, that would rotate this. So instead of being a 3x4, it would be a 4x3. So ANS is a 4x3. Now you see, if I did length of the variable ANS, I'm still going to get 4. It's not giving me just the columns. In this case, it gave me the row. It's just telling you the length of the longest array. If you want to know the size of an array, what you can do is, let's say size of Z. What that will give you is an array. So ANS now has an array. It's 1x2, where the first value is the rows, the size of the rows, and the second value is the how many columns there is. So it's giving you in row column form. Okay, if you do size comma 1, what that will do, so if you only did size in 1, what this will be is give you the first thing from the answer. So this is going to give you the number of rows. If you want to know the number of columns, you could say size Z comma 2. That will give you the number of columns, which is 4. If you don't remember any of these, because it's a lot to remember, but you're like, I remember there is a function MATLAB called the size. How do I use it? Remember, you can type into your command window help and size, and it'll, help and size, and it'll tell you everything you need to know about size. So when you do just one value, and remember that's the array, it will tell you the size of the array as a 2-element row vector. If you feed it in let's see here, size and the dimension, it would tell you, well, rows if you give it a 1, or columns if you give it a 2. Now that we know how to address arrays and determine their size, one thing is useful is you may need to modify an array. So for example, in the 1, 1 address or the 1 column address of Z, there's a value of 16. Well, what if I wanted to set that to 0? I don't have to rewrite the entire array with just a 0 there. I can actually just say assign to the variable z, but only the 1, 1 address the value of 0. So what that will do is assign to variable z, but only in the 1, 1 address the value 0. So what you'll see now is it'll output to your screen the z array. Now, if you didn't want to see the whole array, because you just know what you're doing, it's going to put a 0, but you don't need to see it displayed to your command window. Remember, we could have put a colon. So now here you can see there's a 0 there. What if I did z, and let's say 2 equals 0? Well, remember, this is column indexing, so where should this go? Well, not here, because remember, column indexing goes down. So this would be index 1, index 2. So it will replace the 5 with the value 0. And if I put a semicolon after this statement, there will be nothing to the command window. That doesn't mean it won't execute and assign to z in column index 2 the value 0. It will just not show you that it did it. So let's watch. Okay, and what you see here is there wasn't anything put to the command window, but if we look at this variable z, in that 2, 1, so row 2, column 1, address, there is a 0 now. So you may be asking yourself, well, if I can address more than one row and column at a time, can I assign more than one value at a time? And the answer is yes. So if I go back and say z, and let's just take columns 1 and 3, I don't need a comma there, I could just have a space, 1 and 3, and let's just say rows 2 and 4, and let's put in there a value of -1. And I'm going to not suppress this, or actually no, I'll suppress this output. What we can do is we'll watch in the variable z. Remember how I got this to my command window was that in your workspace, if you double click on a variable, you can see it in this sort of table format. Okay, so when I execute this command in my command window, what I should expect is in rows 1 and 3, and then columns 2 and 4, whatever was there will be replaced by a -1. So that should be this 2, this 7, the 13, and the 12 should get replaced by a -1. So let's try it. And now you see that it has done that. So it was assigning to these multiple addresses this value -1. We can also assign multiple values to an array. So what we could actually do is we can assign, let's try this. So let's assign different values. So we don't have to just assign one value such as -1 to a large chunk of z. So we can redo that last statement, but instead of just passing it a 1-by-1 array, if we pass a matching corresponding array, so in this case I am asking for 2 rows to replace and 2 columns. So if we give it a 2-by-2, it will replace it with a 2-by-2. So let's try that. So let's do -1, and remember, if I want to make an array, I'm going to put it inside the bracket operators. So let's make it -1, -2. To make a new row, I'm going to go -3 and -4. So this is right here, I'm created an array that is a 2-by-2, and I'm assigning that to these addresses in the array z. So what we should get here is 1 right here, a -2 right here, a -3, and a -4. So let's try this. And you'll see that it assigned it accordingly. Now, one thing you'll notice is you need to be careful and make sure your addresses match. So for example, if I just added another number in both columns here, so actually, well, both rows, what I'm doing is now this, instead of being a 2-by-2, there's 2 rows, but there's 3 columns. So let's see what happens when I try to assign this to my first and third row and second and fourth column. It's going to say an error. Why? Well, because when I'm assigning this is a 2-by-3, and I'm trying to assign it to a 2 by 2. So it doesn't know what to do with that third column. So that's why you can't do it. So make sure if you're using multiple array addresses and trying to assign another array, they must match. You can't make it smaller. So you couldn't do a 3 by 2 and assign to it a 2 by 2. That wouldn't work either.